Hello guys, today we're gonna look at um, how to write a test bench for your logic implementation in Verilog code Xilinx ISC design suite. So for that I'm taking an example of full adder circuit diagram. You can see the full adder circuit diagram that is made using a half adder circuit. So this is the desired full adder truth table for three input full adder, and Boolean expressions are as such that the sum should be A XOR B XOR C, where C is the carry in and C out is A B plus B C in plus A C in. So this code we will be implementing on Verilog platform, and we will see and generate the waveforms using a test bench. So let's see how we can do this, and let me switch to the coding part. This is our platform under the project tutorials. I am creating a new source, adding a new file. I am selecting a Verilog module. I will name it as a full adder. Then next, finish. So if you don't know how to define the variables in module, then you can prefer my previous videos, which consist of basic of some how to implement this. I'm today gonna show you in implementation of full order using a structural level, and you can also do that in a behavioral level as well as a gate level too. But here we'll see a structural level. So let's see how we can do it. As you can see in the figure, you will need two inputs, right? One carry input and two outputs. One is sum and one is carry out. Let's define it. A, B, C in, I am giving the name, and sum. Let me write this sum and carry. Right. Now we'll give input A, B, and C in, right? And what is the output? Output is carry and sum. Fine. Now we will take some wires for intermediate things. You can go to the previous tutorial and see the basics of wire. So here I'm taking wire W1, W2, W3. Fine. We'll need to XOR gate. Putting that in one variable. A, B, C, and XOR gate. It is a case sensitive. W1, A, B, fine. There is some XOR 1, this is XOR 2, this is XOR 1, and A, B as the input and one output, as is the output. So instead of A, B, I will write W1. Fine. G1 and G2. So what I did, let me explain you it in a proper way. This is XOR gate 1. So AB is the input and at wire 1 I am giving I am getting an output, and XOR 2 W1 is the input and C in is the input and sum is the output, right? That is the same thing I have done over here. So here in figure it is S, but in the variable we have defined it as sum. Then comes AND gate G3. So how it is done? At AND, A and B are the inputs, and let us take output at W2. Okay, W2, A and B. Fine. Now one more AND gate G4. Let's see what is there. So this AND gate W1 is the input and carry in is the input. So at W3 I am taking output. W3 is the output, W1 is the input, and C in is the input. Fine. Then finally these outputs are taken using OR gate as a sum. So for that we will take OR gate in gate 5. So that is carry. Yeah, sorry, that was carry. And what are the inputs? W3 and W2 are the inputs. W3 and W2. Fine. And we will end it. End module. End module. Let's save it as so. Before running, you need to save it, but I clicked it on run button. The thing is, I have not resetted it as a top module, so first I will do that. Okay, so here I will set it as a top module and will synthesize it. Synthesis XT completed successfully. Okay, so as synthesis part is done, Now we will create a test bench for full adder circuit, and then we will simulate behavior and see the waveforms. For that, we will add a new source. In this, you need to select Verilog test fixture. Then give some name. I am giving it full add TB. TB is for test bench. Then I will give next. For which circuit I am creating? So I am creating test bench for full adder. So I will select full adder and then next and finish. So this is how your TB looks like. So this is the module for test bench of full adder, and this is the unit under test. So these are the input variables and output variables that is need to be tested using a waveforms or possible input combinations. So let's see how we can do further. So A, B, C in are initialized using 0. So next input values we can give is as such: A is equal to 0, semicolon, B is equal to 0, semicolon, C in is equal to 1, semicolon, and then delay of 2 nanoseconds, semicolon. Fine. Then A, we can I can just copy paste this line and we'll change all the possible inputs. So 0, 1, 0, then delay of 2 nanoseconds I am giving. Let's take 101, 101, then again delay of 2 nanoseconds, then we'll take 111, again no delay of 2 nanoseconds. Let's take one more. Let's take 110, 0. Save it. We'll run it. Okay. So this is done successfully. Now we will see a waveform. In this you will see that in full adder TB file you can see. Then so we will select this only. and we will simulate it. Okay, okay. So for 0 1 0, you are getting sum 1 and carry 0. Let's see if this is there in the truth table or not. So what it is, 0 1 0, your sum is 1 and carry is 0. Your sum is 1 and carry is 0. Okay, so this is how we can create a test bench for the logic we need to implement in a Verilog platform. And this is how you can create a test bench. And I taught you from the very basic. I built one program in front of you, very step by step and systematically until end. So try to implement some more different logics, and if you face some difficulty, then give write in the comment section. I will definitely respond and will solve your queries as well. So practice well for more circuits also. And in the next tutorial, we'll come up with some more new tutorial and new methods for Verilog code implementation. And do like and share if you like the learning part. And stay tuned, stay safe, guys. Thank you so much.